Hey guys, this video is going to cover 5.1 on the fundamental trig identities. So chapter 5 is all about identities. We're going to be spending a little bit of time in 5.1. Once you understand how identities work and you get the hang of it, then it's just basically applying it to different identities, and that's what this whole chapter will be about. So in 5.1, we're looking at fundamental trig identities, and a lot of these we've already covered to some extent. They should look familiar, hopefully. We've got your your Pythagorean identities, which is sine squared x plus cosine squared x equals 1. And in just a couple minutes, I'm going to prove how this works. You've got tangent squared x plus 1 equals secant squared x. And then 1 plus cotangent squared x equals cosecant squared x. These are called trig identities, and what it means is that for any angle in here, these are going to be angles. You could, as long as this angle is the same as this angle here, then sine squared of that angle plus cosine squared of that angle will always equal 1. So let's see here. You can also write it using theta, but if you use theta here, you'd have to have the same angle here. That would also equal 1. Let's look at a proof of this. We will, before I do that, we're also going to be looking at the quotient identities, and again, we've looked at those already, so that should look familiar. Odd and even identities, and then we're going to look at something called cofunction identities. They won't all be in this video. I'm going to try to keep these videos short, so that you can focus on the topic that you need help with. Okay, so let's prove this identity right here. Sine squared x plus cosine squared x equals 1. It's those top three identities on this sheet, which, by the way, if you haven't already done so, you can print it off on Canvas, the 5.1 notes, so you can follow along. Otherwise, you can just write it down, pause the video, and write down this in your notebook. Okay, so we're going to prove that sine squared x plus cosine squared x equals 1. Okay, like I said, we can also replace the x with a theta, which I'm going to do, because I'm going to put this on a coordinate grid, and here's my angle theta. Again, no matter what variable you have here, it represents an angle. That's what the sine and cosine and tangent all indicate, that we're talking about. If you have sine of something, that something is an angle measure. So if we have a right triangle here, and we have an angle theta, then this is the side opposite, and this would be the side adjacent, and this side over here across from the right angle is the hypotenuse. So by the Pythagorean theorem, we know that the side opposite squared plus side adjacent squared equals the hypotenuse squared. This is like your A, B, and C. A squared plus B squared equals C squared. Except I'm calling them opposite, adjacent, and hypotenuse instead of A, B, and C. Okay, so that is by the Pythagorean theorem. I'll abbreviate that. If I remember correctly, I think we've been over these before spring break as well. Okay, the next step that I'm going to take is I'm going to divide each of these by the hypotenuse squared, which is just a property of algebra. We can divide or multiply or add or subtract the same thing as long as you do the same thing to both sides of an equation. And then simplifying this, we have the opposite over hypotenuse, which I can write as, since they're both squared, one of the properties of exponents is I can write this as opposite over hypotenuse, that quantity squared. This I can write as adjacent over hypotenuse, that quantity squared. And then hypotenuse squared divided by the same thing is 1. So now I have my 1 that I'm looking for. And if you look at your opposite over hypotenuse, that is, by definition, the sine of an angle. So it's the sine of an angle squared, plus this would be the cosine of an angle squared equals 1, which is exactly what we were trying to prove. So but it's written a little bit differently in this form. when you have the sine of an angle squared, that whole quantity squared, you will often see it written with the square before the angle. And you can do the same thing with this cosine. Cosine squared theta means that quantity squared. Versus if you had something like cosine of theta squared, that is not equal to cosine squared theta. What this means is that the angle is squared, and you would take the cosine of that angle. You'd square the angle first and take the cosine. Very similar types of proofs can be done for these other Pythagorean identities, and you should try it. What you would do to start out to prove the tangent squared x plus 1 equals secant squared x, and again we can call it theta instead of x. Whatever this angle is, it has to be the same variable over here, the same angle measure. So we start out again, same way. I'm going to get you started, but then I want you guys to pause the video and finish the proof. And if you are struggling with it, you can ask me at our next Zoom meeting. Okay, so we would start with opposite squared plus adjacent squared equals hypotenuse squared. That's by the Pythagorean theorem. I'm not doing a very formal proof here. I'm just doing a quick proof. And so now our 1, we need to get this to be a 1 right here. So think about what you would have to divide all 3 terms by. Go ahead and do that division. It would be divide each side by adjacent squared, simplify it, and you should come up with that identity. Okay, I'm going to stop this video here. This is going to be part 1 of 5.1, and in part 2 we will move on to applying some of these identities and also looking at like the cofunction identities.